Assalamualaikum and good morning. Selamat pagi. We meet again for our second session on Thursday 24 today 24 hari bulan. Next week puasa kan? Ke minggu satu lagi puasa? Kita continue balik. We have how many students hari? 29 participants. Okay lah. Cukup forum lah tu. More than 2/3. Right. We were discussing example number 1 tadi. And going back kepada example number 1, a lot of discussion tadi on the data given and data, whatever data that we need to estimate. Contohnya, the most important component would be to estimate the thickness. The same goes sebenarnya pada beam, pada slab, kepada column. Column macam mana pula, sir? Macam mana kita nak tentukan column? Anybody with any idea how to determine dimension of a column? Anyone? Yeah. Sebenarnya beam, slab, column, even staircase ni pun, there is one reference yang kita boleh tengok that we can always refer to, given dalam Eurocode, which is based on fire resistance. Okay, remember that, fire resistance, halangan api. Whatever dimension that we have come up with, based on our L over D tadi, 125 katakan, always refer balik kepada a table given dalam Eurocode based on fire resistance. Okay, so if the building, katakan at the start of the design, we have taken the building, 3-story building, office block to be 1.5 hours fire resistant, 90 minutes. Jadi based on that 90 minutes, dalam table tu will give the minimum dimension thickness untuk slabs, dimension for beams, dimension for columns pun ada di situ. So that table ataupun that reference based on the fire resistance on a building, okay, then that will give a very useful indicator untuk come up with a certain dimension. So for columns, I would suggest to use the fire resistance punya table given dalam Eurocode. You've come back across yang tu sebenarnya when you were doing RC1, if I'm not mistaken. Yeah, RC1 ada looking at the calculation of cover kan. Kita ada based on bond, kemudian based on durability, exposure condition dan sebagainya. And the third one is based on fire resistant. So daripada 3 tu pilih the biggest untuk for the cover of your beam ataupun reinforcement to the beams ataupun reinforcement to the slab. So you've come across that earlier dalam RC1. So that table can be referred to as the minimum dimension for beams, slabs, columns for a given fire resistance punya duration. Sebab tu very important at the beginning of a design of a typical building, let's say a 3-story building. From there we need to clarify, apart from the exposure condition dan sebagainya, the fire resistance of the building. Berapa kita nak guna? Remember, the higher the building, semakin tinggi bangunan, the longer would be the time required for fire resistance. And the maximum fire resistance dalam RC ni is 4 hours, 4 jam. Meaning to say, if there is a fire kat sini, mana dia? Okay. Kalau lah ada api kat bawah ni, if there is fire di sini, okay. Di bawah sini ada api ni. Staircase ni in a building and the building is on fire, okay. Then this staircase is exposed directly kepada api, to fire, right? Fire below kat bawah kan. And this fire resistance will determine, okay, the higher the building, we need a longer fire resistance punya duration. Maximum is 4 hours. So we can safely say that any skyscraper di Malaysia ni, di mana-mana pun lah, kalau the building is in reinforced concrete, then it has to be designed for a minimum of 4 hours because itu yang maximum allowable dalam Eurocode ataupun BS code pun sama juga, Eurocode. Okay, 4 hours fire resistant. So dimension of beam, thickness of slab ni, kalau longer fire duration, maka naturally thickness dia lebih lah. For slab, katakan untuk 1 hour, let's say lah 90 mm minimum thickness. 4 hours, mungkin 200 mm. So that 200 will be the reference of the thickness of slabs untuk fire resistance yang 4 hours punya. So for multi-story ataupun bangunan pencakar langit ni, okay, we would expect the dimensions of the elements, beams, columns, slabs there, will be much thicker daripada normal case. Lebih tebal lagi. Okay? Bigger, wider and thicker elements because of the requirement of fire resistance, meaning the higher the building, the more time is required for the occupants to escape the building. That is why kita provide paling lama is 4 hours untuk bangunan katakan 30 stories, 40 stories. Okay? So everything has to be designed to withstand fire for at least 4 hours. And 4 jam structure is still intact. More than that, barulah there will be failure on the structure, beams collapse, column pun collapse, things like that. Yeah? Tapi a minimum of 4 hours masih lagi intact, right? So kita banyak tengok on this, okay? Now moving on daripada sini, as I've said earlier, we look earlier is to evaluate the GK. Okay, so kita masuk pada calculation lah. Sekarang ni baru masuk pada calculation. Yeah? Okay, the first thing is to estimate the average thickness, and this average thickness is obtained by looking at this equation, multiplying by H, which is the thickness yang asal 110, multiplying by this factor. This factor ni sebenarnya adalah factor due to the inclination of the staircase. Kecondongan, akibat kecondongan tu kalau normal case lah. Kalau saya tak mau guna yang ni pun tak apa. I need to use sin, cosine, angle, dapatkan angle, gunakan sin, guna cosine, dapatlah dia punya average thickness pun boleh juga. Tapi this simplifies lah, tak payah nak guna sin ke, tak payah nak guna cosine ke, tak payah, we don't need to even know what is the angle kat sini. Okay? What is this angle pun, we don't need to know. What we need to know is these two values sahaja, R dengan G. So R and G is substituted in this equation, G squared plus R squared, square root kan semua sekali atas ni, divided by denominator G. The value indicated di sini is usually untuk public buildings is about 1.2 to about 1.3 lah, lebih kurang. 1.2 to 1.3. Kalau kita evaluate di sini, this value sahaja, berapa dapat Hasnita? Kalau yang ini saja, 255 squared, okay, 255 squared campur 175 squared, square root kan dia, bagi 255. Nilai di sini sahaja.
1.21.
1.29.
1.21.
1.21. Okay. So dia lebih kurang between 1.2 to 1.3. That is for normal R dengan G lah untuk public buildings lah. About 1.2. So daripada situ kita dapatlah nilai Y di distance yang ini. Asalnya yang ini. Remember our H ni, the original H is yang ini, 110, 110. This is the original H. Now this H ni kita jadikan dalam arah vertical because remember our gravity load is in a vertical. Jadi kita nak dapatkan GK ni dalam arah vertical. So this thickness of 110 is converted kepada thickness yang vertical Y. Therefore, maka untuk tu maka nak dapat the average thickness of T. Okay. This average thickness of T, what we do is Y plus R campur Y. This value campur this value. This value is y. Yang ini total dia y plus r. Okay? Y sampai sini and then plus r di sini. So y plus r bagi 2, take the average. So dapatlah average thickness 2 to 1. So this is the average thickness yang akan digunakan, they will be used to obtain the GK acting in a vertical punya gravitational punya direction, gravity, arah gravity. Right? So this is how we evaluate the average thickness. And moving on, from the average thickness, maka dapatlah dia punya, save dulu. Okay. Dapatlah dia punya total GK. We obtain the total. From this average thickness 2 to 1, multiply by density. Remember density concrete? I've said earlier, for grade of concrete between not exceeding 50, maka density dia constant, 25 kN per meter cube. Okay. Multiply by thickness, dapat per meter square. So loading on slab, loading on staircase is always per meter square. Kalau loading on beam is per meter panjang, per meter run of the beam, per meter length of the beam. Untuk slabs dan juga staircases, it is always per meter square. Okay. So we have our self weight plus our finishes. This will give us the total GK. And this is our total QK. From these two values, GK dengan QK, maka dapatlah kita punya design load 1.35 GK plus 1.5 QK. Harap-harap masih ingatlah, hoping that you all still remember the equation yang digunakan to evaluate the design load, which is 1.35 GK plus 1.5 QK from your previous RC1. Okay, previous RC1. So this is the value 14.8 kilonewton per square meter, approximately lebih kurang lah 15 kilonewton per square meter. Okay, now kita multiply yang ini with 1 meter width. Okay, remember slab pun macam tu kan, multiply by 1 meter width of the slab. So staircases pun kita ambil pendekatan yang sama, the same approach. We are multiplying this loading ni to be for every 1 meter width of the slab. Remember, dalam equation, dalam this problem ni, there is no mention on the width of the staircase. Okay? Tak dimension langsung. It's not even mentioned what is the width of the staircase. Is it 2 meter wide? Is it 2.5 meter wide? Is it 3 meters wide? It's not mentioned at all. Because we don't need that information. Why? Because we are designing for every 1 meter width of the staircase. So it doesn't matter. Kalau kita dapat sini, if the actual width of the staircase 2.5 ataupun 3 pun tak apa. Because from here, from the loading of kilonewton per meter width, we will then evaluate dia punya AS nanti. Dan AS dia, the reinforcement will be in the form of millimeter square per meter. Ini lain sikit daripada beam. Kalau beam millimeter square saja. Kalau slab millimeter square per meter. Staircase pun sama. We're dealing with millimeter square per meter, which means to say that the reinforcement will be in the form of, for example, H8 at a spacing of 150. Okay. So this will be the form of reinforcement that we will be expecting untuk staircase. So we have a diameter, we have a spacing. So it doesn't matter how wide the staircase is going to be, as long as we have a certain dimension, a certain diameter, and a certain spacing that is sufficient to provide the reinforcement for the staircase. So remember, our loading is asalnya per meter square, multiply by 1 meter width, maka all the calculations will now be in kilonewton meter per meter width for the bending moment. Shear force will be kilonewton per meter width. Loading will be kilonewton per meter width, and so on. Yeah. So this would be kita punya approach untuk design for the staircase. Okay. Any questions so far? Ada soalan? Ada? So this is the schematic The idealized structure shown as kita punya beam. Okay. This diagram is something that we have come up earlier. From looking at the problem tu, we have already come up with what it would look like, the direction of solution tu kita dah tahu. Cuma sekarang ni, we are now putting in the figures. We are putting in the values. Nilai-nilai sahaja yang dimasukkan. Okay. So now we have a value of approximately 14.8. Okay. Kalau ikut sini 14.8. Kalau saya pakai 15 saja sini. 14.8 kilonewton per meter. Remember, it is per meter width. So yang ini pun sebelahnya kilonewton meter per meter width. This is kilonewton meter per meter width, the bending moment. The bending moment is obtained by using this equation. Hanya dua equation saja you have to remember. FL/10 for continuous, and the value is sama untuk sama ada negative bending moment, okay, ataupun positive bending moment. The value is the same. Okay, so the value sini 11.6, 11.6, 11.6. So for a continuous case, sama ada it is a positive sagging bending moment or a negative hogging bending moment, the value can be obtained, the values are the same, and it can be evaluated menggunakan FL/10. This is the equation that we are going to use to identify the bending moment for a continuous case. For a simply supported case, kalau ada tangga yang simply supported, if we have a case where katalah this part dah tak ada, there is no continuity on the left hand side dengan right hand side, so we have something macam ni. We have our loading, okay. Then the bending moment would be a simply supported bending moment. The value would be FL/8. FL bagi 8. And this is applied kepada simply supported case. The bending moment. Untuk continuous case, it is FL/10. So you have only these two values yang perlu that you need to remind yourself lah, that these are the two values. Satu is FL/8 dan satu lagi FL/10. It depends sama ada it is a continuous ataupun a simply supported case. So, but whatever the bending moment can be obtained by using these two equations. FL/10 to show ataupun to be used for continuous cases, manakala FL/8 is for simply supported cases. Right. So looking back pada sini, the bending moment is FL/10. F is the nilai F ni adalah the total load. Remember that? This is the total load. And how do we obtain the total load? Is by loading multiply by span. Ni. The load di sini, okay, is obtained by W times L. W is 14.8 multiplied by our L, which is our span, dan daripada situ dapatkan nilai F, which is approximately 41.5. Okay. And this 41.5 will then be used in FL/10. Again, L di sini referring kepada total span L, dan multiply by divided by 10, maka dapatlah 11.6. Okay. So now we have all the values. Initially daripada awal kita dah tahu we've already we have already come to a solution that it will be a continuous staircase with bending moment yang macam ni. Sekarang ni is now when we actually have the values, right? And selepas pada ni is to design the reinforcements. Once we have this value, okay, we need top reinforcement pada penyokong. We need top reinforcement pada penyokong, right? And we need bottom reinforcement pada span. We need bottom reinforcement di sini. Okay. We need bottom reinforcement. So for positive bending moment, we need bottom reinforcement, and negative bending moment, you need top reinforcement. And this will form kita punya basis of detailing nanti later on. Yeah. Moving on, now kita evaluate. we already have our bending moment. Maka if you notice the equation that we are using ataupun the equation shown di sini, these are the basic equations of a rectangular section. Okay. A rectangular section yang mana lebar B is taken as 1 meter. Remember we multiply awal-awal tadi, multiply by 1 meter. So now it means to say that the width of the rectangular section is 1 meter because we have converted all the loadings tadi kepada kilonewton per meter kilonewton per meter length per meter width. Okay. So yang ini basically the first part of the equation is to check whether it is a singly ataupun a doubly reinforced punya section. Okay. And I have never come across normal staircases yang doubly reinforced, belum lagi. Semuanya singly reinforced. Yeah? The argument being the bending moment we are dealing with is 11, 12, paling besar pun mungkin 20, 30 kilonewton meter. Bukan macam beam. We have 250 kilonewton meter, 300 kilonewton meter. The bending moment untuk beams, typical beams. Okay? Now we are dealing with just bending moment 11, 15, 20, 30 kilonewton meter. So naturally, we would not be expecting any doubly reinforced section. Okay, everything will fall under singly reinforced. So yang ini is just to verify that the section is singly reinforced, tak perlu tertulang berganda, menggunakan tertulang tunggal sahaja, singly reinforced. Compression reinforcement is not required because the K value is less than 0.167. Okay. This is one way lah membandingkan K dengan 0.167. This is what is recommended dalam Eurocode. We calculate what is the value of K and then kita comparekan dengan 0.167. If the value is less than 0.167, then singly reinforced. If it is more than 0.167, then it is doubly reinforced. Tertulang berganda. Saya lebih suka compare bending moment. Maksud saya kira dulu M capacity of the section, which is equal to 0.167 multiplied by FCK K darabkan dengan FCK BD squared. Okay, Asmita, berapa dapat ni? FCK 25, B 1 meter, D kita ada berapa ni? 81. BD squared. 0.167 FCK BD squared. Dapat berapa moment capacity dia? 100 2 lebih ya? 200 lebih kurang 233. 233, betul? Okay. Kilonewton meter per meter width. This is the maximum moment yang boleh ditanggung that can be supported ataupun that can be supported by the staircase, yang mana H average dia is 221 mm. This is the maximum capacity of this section, 221 punya average thickness. It can support a maximum moment of 233. So the applied moment is only 11 point something. 12 lah. 12 pun tak sampai 12 pun kan moment ni. 11.6. 11.6. So the applied moment is very much less than the capacity. So it is singly reinforced. Unless the applied moment is 250 kilonewton meter, baru bermakna tertulang berganda, doubly reinforced. Now the bending moment, applied bending moment is only about 12 kilonewton meter. The capacity of the section, it can support a moment of up to 233 kilonewton meter based on this equation. Clearly the section is a under reinforced section. Okay. That is another way of looking at. Yang itu saya compare the capacity, moment capacity of the section, comparekan dengan the applied moment, moment yang dikenakan due to loading, which is only about 12 km/meter. Anyway, kalau gunakan what is recommended dalam Eurocode is comparing this ratio dengan K. Saya lebih suka compare moment dengan moment. Nampaklah sikit dia punya dia punya orang kata justification dia tu. Then of course kita dapatlah nilai AS based on the value of Z should not exceed 0.95D. Therefore kita dapat the area required is 353 mm² per meter. Okay, 353 mm² per meter, and this value is then comparekan dengan minimum reinforcement which is 108 and maximum, of course maximum dia 4,000 plus lah. We are not using that. Okay, so 353 tu is somewhere di sini. Okay lah tu. Greater than minimum, less than maximum. Is located somewhere di sini, in between. 353 is somewhere di sini. Between 108, kita ada 353. It is greater than 108, but less than maximum. Okay, so that is how kita obtain the reinforcement, and from this reinforcement, maka this is selected. Now, yang ini saya savekan dulu. We need to look at the steel table. Kat mana nak tengok steel table? Sekejap. Saya masuk RC2. Eurocode. And let's have a look at yang ini. New share. I'm looking at this. Okay. Ini table dia, steel table. Okay. This is a steel table yang I think everyone is familiar. The same table yang you referred to when you were doing your RC1 earlier. The same table we are going to use for RC2 juga, untuk staircase, untuk foundation, untuk pile cap, untuk column, untuk column, semua lah. Retaining wall, still referring pada table yang sama. So ada dua. One is based on millimeter squared, AS dia. The other one, the lower table is millimeter squared per meter. So we are referring kepada this table. Table yang ini. Table B. Sectional area per meter width. Okay. We are referring to this for staircase. And for slab juga, for that matter. Now, we have decided earlier that we are going to use 8 mm. Assumption dia. And what is required is sebenarnya we have an area of 3 from calculation 353 millimeter squared per meter, right? And looking at 8 mm 353, then it is somewhere di sini lah, yang ini. So from there kita dapat H8 at 125 spacing. H8 at 125 spacing. So this will be kita punya spacing. Where the area provided is now 402, greater than 353. Lebih pada 353. Okay. So this is how kita come up with the reinforcement. Looking at the diameter, we have our calculated AS required, dan 402 is the AS provided. Okay. H8 at 125 is the area provided. It gives an area of 402 millimeter squared for every 1 meter width of the staircase. Right? We can even choose to have a different. Katakan I want to choose, saya gunakan different color. 10 mm. Boleh juga. Okay. 10 mm. Kalau saya gunakan 10 mm, then my spacing would be somewhere di sini. This would be my spacing. 200. Okay, 200 mm. This would be my spacing. 200. H10 pada 200 spacing. where my area is 393. It's bigger than 353. As long as more than 353 tak apa. So we can have either H8 ataupun yang ini warna biru ni is H10 at 200 spacing, where my area provided is 393 millimeter squared per meter. Or I can choose H8 di sini, H8 at 125 spacing, where the area provided is 402, okay, 402 millimeter squared per meter. So you can either choose H8 at 125 pun boleh, H10 at 200 pun is okay. Right? So this is how kita come up with the reinforcement for the detail of the reinforcement untuk staircase. Right? Any question? Say dulu. Okay. Okay, sometimes we need to use ataupun yang dicadangkan is more than 300 spacing. So how do we calculate the area? Kalau if we look in detail, secara detail, let's take an example. 10 mm at 100 spacing, comparekan dengan 10 mm at 200 spacing. The spacing is double. Okay? The spacing is double. Kita perhatikan the area di sini dengan the area di sini. This area is half. Yang ini 2 times, 2 kali. Double the spacing, the area becomes half. Bermakna if I want to use katakan H10 at kalau lah saya katakan, let's say for example H10 at 350. I want to use 350. Tengok dalam jadual mana ada 350, 300 je maksimum. So what we do is 350 is now taken as kalau kita bagi 2, 350 ni, it is 175. We have H10 at 175, which is 449. Maka H10 at 350 would be half of 449. 228.5. 229 lah. 229. So this area of H10 at 350 is 229 millimeter squared per meter. Okay. So this value of 229 is taken as half of 449. 449 is spacing 175, which is half the spacing of 350. So the bigger the spacing, the less will be the reinforcement. The smaller the spacing, the more will be the reinforcement. Okay. Bermakna 100 spacing dengan 200 spacing. 100 is 789, 200 is 393. This value is half. 393 itu is half of 789. Bermakna once we double up the spacing, then the area becomes half. Half as compared kepada before kita double up the spacing. So on that argument, maka 350 before doubling up it is 175 at 449. The double 175 dapat 350, maka the spacing will be half of 449. Maka dapatlah 229 millimeter squared per meter. Okay. So ini just in case lah kalau we intend to use spacing yang not recorded di sini. Sama juga macam ni. If I want to use 12 H10, I have only about 10 di sini. But I know the diameter, the area for one H10. So one ni kalau if I want to use 12, 78.5 times 12 lah, dapatlah total area for 12 number of bars 10 mm diameter. Walaupun dalam table is only about maximum is 10 numbers. But we can always evaluate any value greater than 10. Yang ini pun we can evaluate the value of the millimeter squared per meter more than 300 spacing pun masih boleh dikira. Alright. Okay. So any question? Anything that you would like to discuss based on kita punya discussion today? Kita belum habis lagi. The first example, slow and steady. Yeah. And from that reinforcement, maka dapatlah yang ini. H8125, remember, is the bottom reinforcement. H8125 juga should be the top reinforcement. Cuma yang ini mungkin terlupa lah. We should add another reinforcement di sini to indicate kita punya top reinforcement. Okay. The rate reinforcement ni tambahan. H8125 juga. And the green reinforcement yang bawah ni, yang di bawah ni sebenarnya is a reinforcement that is not designed. Bukan kita design ni pun. It is a reinforcement indicated di sini, ditunjukkan di sini, coming from adjacent slab. From this slab, there is reinforcement. Cuma it indicate di sini that the reinforcement is then anchored ke dalam the staircase. But it is not the reinforcement that we are designing. What we are designing is the green reinforcement yang ditunjukkan sini and the red reinforcement. Itu yang the main reinforcement lah. Similarly, di bawah ni, this is the green reinforcement that we have designed for, which is the maximum. Yang ini ni sebenarnya is not something that we design. Sebenarnya it is the reinforcement coming from the adjacent slab being anchored ke dalam tangga. It's not something we design. It's not termasuk dalam solution. Okay? It is something to indicate that the adjacent reinforcement from the slab yang sebelah sini on the right hand side dan slab sebelah sini on the left hand side, there will be reinforcement dalam slab and that reinforcement is indicated to be anchored dalam staircase as shown, sebagaimana yang ditunjukkan. Okay, as shown. Cuma di sini there is a gap sikit lah between reinforcement hijau yang ini dengan yang hitam. So I would recommend that kita tutupkan this gap ni dengan our main reinforcement. Okay. So this is basically the detailing based on the reinforcement that we have designed H8125. Remember the black one, dotted line yang warna hitam tu, this is the reinforcement from the adjacent slab bersebelahan that is shown and shown to be anchored dalam staircase. It's not something yang we design. Okay. Apa yang kita design ialah the red and the green reinforcement sahaja. Okay. The black dotted line tu is actually reinforcement coming from the adjacent slab and anchored into the staircase. Okay. Kita tak tengok detail lagi lah. Just to share. At this stage we already have the reinforcement. Okay. Bila dah ada reinforcement yang ni, then kita tengok yang tu. Roughly how is going to be detailed out. Secondary bar di sini ditunjukkan H8350. This is obtained based kepada AS minimum. AS minimum is 108. So kita gunakanlah about as long as bigger than 108 dah cukup lah. Jadi secondary bar ni can be referred kepada AS minimum ataupun at least 20% of the main reinforcement. So main 20% is only 70 watt, less than AS minimum. Maka digunakan AS minimum. Alright. Any question? We have less than 1 minute. We have kita dah pukul 10. You might have other classes today. So I think I'll stop here dulu for today, for this week, and kita akan jumpa balik next week on Monday. Betul?
Betul.
Alright, so have a good weekend ahead dan jaga kesihatan, stay safe. So assalamualaikum.
Thank you, Dr. Assalamualaikum.
Kepada all. Alright. Okay, we meet again on Monday next week. Alright, okay.
Thank you, Dr.